Thanks, everyone. I'm really happy to be joining you this afternoon. And I have the great pleasure of introducing Beth McClarty-Halfkenny, who's the curator and outreach coordinator for the Department of Earth Sciences at Carleton University. Now, Beth has a very long and extremely impressive list of accomplishments and accolades that all seem to cluster under the umbrella of her commitment to geoheritage and to science outreach. She teaches students and she teaches educators. She advocates and she organizes. She created a successful public outreach event called Geoheritage Day, held annually each fall here in the National Capital Region, that aims to help facilitate local engagement with geological histories that have shaped these landscapes. She currently serves as the president of the Canadian Federation of Earth Sciences. I first met Beth years ago when she ran a workshop that involved the Earth Sciences collection as part of an experimental pedagogy project I was co-leading at Carleton. More recently, our paths crossed again when Beth did a placement at Ingenium and worked with some of our very exciting drill bits, and she connected them back to places and to communities. We bonded over our interest in geoheritage. Beth is 100% the expert, and I am fully the student, and there's no better person in Canada to speak about geoheritage, which is an understood and important topic that is literally foundational to our lives. I'm going to hand it over to Beth, who will speak for about 45 minutes. Then we will open up the floor to questions. And when you're ready, please put the questions in the Q&A. Thanks so much. Take it away, Beth.
Thank you, Rebecca, for the very kind introduction, and to Moira for your support during this virtual webinar. I'm delighted to join you today and talk a bit about my work in earth science outreach, specifically in helping people understand our local geoheritage, which we hope will in turn help connect people more closely with the place where we live. As we begin, I'd like to add to the land acknowledgement offered by Moira, just to say that as a geoscience educator, I have a privileged opportunity to think about deep time and the importance of place, and I would like to acknowledge the connection of the land that Indigenous people have had since time immemorial, and the tremendous value Indigenous traditional knowledge and practice bring to the work of storytelling about the earth. So the first question I think people have is, what is geoheritage? So where did this idea come from? So the Western concept of geology as heritage was first discussed at the International Symposium on the Conservation of Our Geological Heritage at Digne-les-Bains, France in 1991. You will see the document that was produced. Participants of this meeting produced a document called the Declaration of the Rights of the Memory of the Earth, which noted the unique nature of planet Earth and the need to protect its geological assets as an integral part of the natural heritage of our planet. It may be difficult to see the document as printed, but I pulled out a couple of things that are interesting to me. The first one is tenet number 6 of 9, which says Earth retains memories of the past and a record which can be read and transcribed. This is interesting to me as a geoscience educator because we often talk about reading the rocks or telling the stories that the rocks can tell us. And number 8, man and the earth share a common heritage of which we and our governments are but the custodians. I thought that was a particularly interesting idea that came out of this meeting. So I think this is an interesting document that begins the conversation among Western scientists to recognize this deep connection between human societies and the earth and the need to protect it. So since that time, various definitions for geoheritage have been proposed, with the following being the most complete. The word is derived from the idea of geological heritage, meaning the heritage of the abiotic or non-living elements of our natural heritage. This part of the natural environment underpins the biological and human environments and ecosystems on the planet, providing the various niches, landscapes, and resources necessary for biodiversity and human habitation. Two other definitions here: heritage, meaning what has been inherited from the past, and geosite being a site of geological significance. Lately, there has been a push to recognize geodiversity, or the diversity of geological landscape features and processes on Earth, and to think about protection and preservation in much the same way we think about protection and preservation of biodiversity. Many would argue that protection of biodiversity hinges on protection of those varied geological landscapes on which ecosystems rely. In 2021, in November of last year, UNESCO declared that October 6, 2022 would be the first annual International Geodiversity Day. And I will tell you a little bit more about our ideas to celebrate that event in a couple of weeks later in the talk. Apologies, I'm sorting my notes. I encourage you, there's a little picture in the bottom right-hand corner. I encourage you to check out this 3-minute video produced and narrated by Ian Stewart in 2021 that does a really good job of making this connection. It's called Geodiversity, Biodiversity's Silent Partner. If we have time at the end and technology being agreeable, I can show it to you. Otherwise, I encourage you to go find it. You just have to Google those words and you should find it with no trouble. And it's a three-minute watch. Internationally, there are several institutions that work to protect geological heritage. The UNESCO World Heritage List currently includes 1,154 sites worldwide, of which 76 are inscribed on the basis of geology. They need to meet one of 2 criteria, be a natural landscape or feature of exceptional beauty, or an exceptional example that records some aspect of Earth history, such as the record of life, geological processes, or significant physiographic features. In Canada, half or 10 of our 20 sites on the World Heritage List are recognized, at least in part, for their geological values. UNESCO Global Geoparks are another avenue for documenting and showcasing geologically important areas. To date, Canada has 5 UNESCO Global Geoparks and 6 aspiring geoparks, meaning they are working towards becoming part of the network. This designation involves some aspect of community economic benefit, along with public access to learning experiences centered on the geology. The IUCN, you'll see their logo in the little corner there, is the International Union for the Conservation of Nature. It started about the same time as UNESCO and is concerned with natural heritage. It began in the US, where their national parks have a specific mandate to protect geologically important sites. So a little bit different than here. In Canada, when we collectively think and talk about heritage, we are most often talking about cultural or human heritage. Our natural heritage is not mentioned specifically, but is managed by various levels of government within Parks Canada and Environment Canada, which is now called Environment and Climate Change, and mostly, perhaps fortunately, caught up in environmental protection mechanisms. Our World Heritage sites are generally within existing national parks and as such are managed by Parks Canada. Parks Canada is in fact the most important protector of geologically significant sites. Most of our national parks were created out of a need to protect the stunning landscapes. This indicates an awareness among the Canadian public of the importance of protecting them, but less awareness of the geology that underpins that landscape. Lastly, within the provincial governments, we have various mechanisms for addressing geological assets. In Ontario, we have the ANSI designation, which is a list of areas of natural scientific interest. This doesn't offer any protection, but can be used to show that the site has previously been investigated and important geologic features of value have been documented. In Ottawa, there are several ANSI sites, and we will talk about a few of these. There are some provisions for documenting and protecting important fossil discoveries in Ontario and federal legislation. In much the same way archaeological artifacts are managed during construction or site rehabilitation, but nothing mentioning geology more broadly. So some of you may recognize this fella. The Friends of Canadian Geoheritage is a grassroots movement begun by retired Carleton professor and sedimentary geologist, Dr. Alan Donaldson, in 2003, and was formed to address this problem of lack of public awareness and to promote recognition and preservation of Canada's important geological heritage. Shortly thereafter, Al gathered together interested volunteers to form a locally focused group, the Ottawa-Gatineau Geoheritage Project, of which I am a member. The goals of the project are to find ways to preserve exposures of geologically significant areas in the National Capital Region by encouraging local authorities to recognize, preserve, and protect these sites. Our key activities involve preservation so as to minimize the loss of irreplaceable geological and landform features, protection via strengthening and enforcing applicable laws and regulations, and promotion and public awareness through informative signage, brochures, displays, talks, and public events. We feel that greater recognition of geoheritage assets in the National Capital Region will add an important missing layer to the interesting heritage stories we can tell about the place we call home. So what exactly do we do? The group promotes public awareness of geological history of the area at public events by giving talks like this one today, and by working with both the City of Ottawa and the National Capital Commission, or the NCC staff, to identify and document geological assets under their control. We have successfully rescued blocks of Cambrian age sandstone. You'll see them being jackhammered out in the bottom right-hand corner of your image. These rocks were slated for demolition during the expansion of Highway 417 as it passes through Canada. Dr. Donaldson was able to negotiate with the construction company, the City of Ottawa, and the Ministry of Transportation. The construction company Kavanaugh kindly agreed to jackhammer some blocks out rather than blast them to smithereens. And we were able to relocate these blocks to Carleton and Ottawa-U campuses and to the Metcalfe Geoheritage Park in Elmont, where they can be further studied and observed. Members of the Ottawa-Gatineau Geoheritage Project have been working with NCC to identify and document geoheritage features at the Victoria Island property and advising at Nepean Point during site rehabilitation work. We were contacted actually a couple of weeks ago to advise on proposed signage that will highlight a stromatolite exposure along the Ottawa River as part of the redevelopment of Westboro Beach. So we hope to continue building these relationships and collaborating on public awareness of geosites in the National Capital. So we briefly looked at a definition, but, oh, hang on. We briefly looked at a definition. I need to find something, 1 second. Here we go. But what is a geosite? So in the context of the work that I do, generally a geosite is a place that's geologically interesting and hopefully visually interesting, because I want the public to get excited about it. It could show evidence of the processes that have shaped the landscape or the various life forms that have called this area home over the course of geological time. And along with these aspects, for my purposes, which includes public education, a geosite must be easily accessible, safe, and on property that is open to the public. So now that we have a bit of context about the idea of geoheritage, let's have a look at some of the geosites in and around the National Capital Region that I think are quite remarkable, beginning with some examples of the oldest rocks in the area. So this fabulous spot. So this is a place which is private property, actually. The owners are very excited about the rocks on their property, so they are happy to have people come and stop by and have a look. This is called Place Gascon. It is a plumbing company, I believe. But when they were building their new facility, they discovered this bedrock in the corner where they wanted to put their septic tanks, but were not able to. And so they have power washed it instead. So the outcrop's located within the Grenville province, the youngest southernmost part of the Canadian Shield, and is thought to have formed about 1 billion years ago. The rock is classified as a gneiss and contains alternating bands of mafic, or dark colored iron and magnesium rich minerals, mostly micas and amphiboles, and felsic, or light colored silica and aluminum rich minerals, mostly quartz and feldspar, so alternating light and dark. The banding indicates that this rock began as a sequence of sedimentary rocks, including sandstone, shale, and mudstone, that was subjected to intense metamorphism, which those who study the Grenville province suggest happened during the collision of ancient crustal plates. A high temperature is suggested by ribbons within the dark bands. You'll see those near my feet in the far left of your image, the lower left. So within the dark bands, we have some large amphibole crystals that seem to be the result of partial melting and recrystallization. We can see some folding in the rocks and faulting, granitic intrusions or dikes that crosscut other features. And so they could have been intruded during the metamorphism event. Together, these observed features suggest this rock formed tens of kilometers beneath the ancient Earth's surface, representing the exposed roots of an ancient mountain system. The deformation helps us to make estimates about the scale and height of the ancient mountains that once stood here. Some have suggested they were higher than the present-day Himalayas. 1 billion years of weathering and erosion subsequently of those mountains have exposed these rocks at the Earth's surface, where they were subjected to further erosion during the last glaciation, as indicated by the very smooth and polished surface of some of the quartz-rich bands. Moving on to another Precambrian site on this side of the Ottawa River. These rocks in the Canada Schoolyard are at the southeastern tip of the landscape feature called the Carp Ridge. It's an extension of Precambrian rock that, although older, sits above the surrounding younger rock. The Carp Ridge represents the oldest exposed bedrock south of the Ottawa River, and like the rocks in Kentley, they are composed of 1 billion-year-old metamorphic rock called gneiss. These rocks are often referred to as basement rocks. They occur underneath the whole region, and we find them when we drill holes through the overlying younger sedimentary rocks and glacial sediments. The current shape of the outcrop is a result of glacial erosion during the last ice age. Abrasion of the bedrock surface under the moving ice sheet has produced a classical glacial landform known as a roche moutonnée, translated as a sheep rock. The outcrops look like a field of grazing sheep, essentially. These landforms have a smooth sloping upside and a steep irregular down ice side, which gives us evidence of southward movement of the Pleistocene ice at this locality. The gneiss displays alternating light and dark bands containing quartz and feldspar and mica, amphibole and garnet, respectively. And as we see at the Kentley outcrop, the intense deformation and folding of the bands has caused some minerals to recrystallize. And at this location, there are some very large garnet crystals. You can see a couple of them and the spaces where they've been plucked out in the picture on the upper right with the nickel for scale. Igneous dikes of coarse-grained quartz and alkali feldspar cut across the gneiss exfoliation. Some pockets of tourmaline can be found, and then dark-colored igneous intrusions of fine-grained diorite can be traced from outcrop to outcrop across the schoolyard. So this is a really wonderful mapping project for students. This spot is probably recognizable to lots of people. This is the Champlain Lookout. This is a place where we go to do what geologists call arm waving when we want to talk about big picture, big ideas. It's a spectacular spot to view the regional landscape and to think about all of the events and processes that occurred over time to produce what we see now. The lookout sits atop the Airdrie Escarpment, assumed to be an extension of the Airdrie Fault System, which developed about 175 million years ago. We say presumed, as the contact between the Gatineau Hills and the Paleozoic rocks below is not exposed where we can see it along the escarpment. What we can see from this vantage point is the Ottawa-Gatineau Graben. This is a fault-bounded valley that runs from Montreal to the south up through Mattawa to the north. Cambrian and Ordovician age sedimentary rocks, so 540 million year old sandstones and 450 million year old limestones and shales, were preserved in the down-dropped block within the Ottawa Valley, protect from weathering and erosion, unlike the Precambrian rocks on the higher ground to the north. The flat-lying Paleozoic sedimentary rocks are overlain by unconsolidated sediments. That means that they're not become rock yet, deposited by retreating glaciers about 10,000 years ago. What is estimated as 2 kilometers of ice formed during the last ice age, depressing the landscape, allowing seawater from distant Atlantic to make its way to Ottawa, creating the Champlain Sea. With the melting of the ice, the landscape rose again. The sea retreated, leaving behind thick deposits of silt and clay, including the famously sensitive Leda clay in low-lying areas. This is also the feature that creates the interesting microclimate in the Ottawa Valley, different growing zones, bird migration, all due to this faulted down-dropped block. Also, it creates our earthquakes that we have along these previously active faults. Next youngest, we have a spot in Nepean where we can find the Nepean sandstone. Moving upwards in geological time, we can find Cambrian sandstone all along Highway 417 as you ascend the hill west of Ottawa, traveling towards Canada. It's mostly accessible in the parking lot of the Centrum shopping mall. This vertical section is thought to record thousands of years of sand deposition around 540 million years ago. It's quartz-rich sandstone with abundant crossbeds within the depositional layers, representing ripples that record current direction at the time of deposition. Some ripple marks are preserved at the top of one of these exposures, and a few millimeter scale depressions interpreted as raindrop impressions can also be seen. The reddish discoloration that can be seen along the highway is due to iron that has infiltrated the cracked surfaces, producing oxide staining. Nepean sandstone is one of the local building stones used in the Parliament buildings, and you can sometimes find old quarry sites near the 417 along the NCC pathways. The sandstone is very clean, meaning it is mostly quartz, well cemented with fairly uniform sand grain size. By thinking about where we might find such a large amount of quartz-rich sand today, we can imagine that our area was once a beach environment at the edge of an ancient continent where the sediments could be washed by wave action, taking away the fine materials to be deposited elsewhere and leaving behind a relatively uniformly sized quartz sand. This next spot is one of my favorites, situated below the west of the Champlain Bridge on the Gatineau side of the river, lies an exceptional exposure of a feature that can be seen at various sites throughout the area. During low water events, such as happened last September, this spectacular expanse of circular mounds begs investigation. These rocks are Ordovician in age, some 460 million years old, and are part of the Pamelia Formation. These structures formed when mats of bacteria trapped sediment, sand grains within them, growing upwards through the water column, ultimately creating this pavement of circular, finely layered sand mounds called stromatolites. Currently on Earth, these structures are being formed only in a few places under extreme conditions. You can see one of those places pictured in the top right of my slide in Hamelin Pool in Australia, which is near Perth. They have also been found in the Bahamas in a zone of extremely strong tidal currents. Both of these environments prevent grazing organisms from eating them, and so it begs the question of what does this tell us about the paleo environment of this area during this part of the Ordovician. Apparently, there are fossils of gastropods that might have grazed on stromatolites in older rocks below this location, but they are very rare in this location, suggesting the spot was perhaps also inhospitable to grazers at the time. The next spot is one that lots of people visit. Prince of Wales Park and the Hogsback Falls allow us a close-up look at another major regional fault that runs perpendicular to the Ottawa-Gatineau Graben, and right underneath my feet right now at Carleton University in the Earth Science Department. This is called the Gloucester Fault, and it also gives us a glimpse through time via the vertical surfaces. This is a favorite spot to take our students to study rocks in their natural habitat. Here we can look at sedimentary structures left behind in the layers of rock and think about what environment might have been like there during the Ordovician, and about what has happened to these sediments since they were laid down, cemented, and compressed into sedimentary rock. From the pedestrian bridge, this central image, looking north along the falls, three formations are exposed. Oldest are the green shaly sandstones of the Rock Cliff Formation on the left or west side of the falls, and on the right or east side of the falls are younger rocks, thin beds of shale, sandstone, limestone, and dolostone of the Hogsback Formation, overlain by younger shales, limestones, and sandstones of the Pamelia Formation. These three formations record variations in depositional history and sea level over about 10 million years. Slight folding and several faults have disturbed the once horizontal sedimentary rocks. We can see from this vantage point that the rocks on either side of the river tilt away from the river. So then, if we look below that central image, sedimentary structures that can be seen along the west side of the falls include variable shapes of ripple marks. They record depth and direction of flow of the water at the time of deposition. Glacial polishing and striae can be seen on some parts of the uppermost surface. And the Rock Cliff Formation sandstone contains more feldspar, mica, and lithic grains, meaning stone pieces, compared to the quartz-rich Nepean Formation sandstone that we saw earlier. On the right-hand side, east of the river, you can just see the colors that the material composing the layers is more variable, and the thickness of units is more variable. The lower Hogsback Formation consists of dolostone, limestone, and shale, and the Pamelia Formation at the top of the cliff section is composed of bioturbated sandstone. Bioturbation, which is hard to say, just means that animals have moved through the sandstone and left traces of themselves and their activity. It has also contained shale and fossiliferous limestone beds. The washroom building in the park is made of Pamelia Formation limestone quarried a short distance away from the river within the park. And in the washroom stone blocks, you can find abundant brachipod fossils. A small but good section of stromatolite is located at the beginning of the trail on the east side of the falls, nearest the railing, and it shows a cross section of some small mounds so that the internal layering structure can be seen. The configuration of the rocks on either side of the falls suggests that right or east side has dropped down relative to the left or west side, and that the large block in the middle has fallen in from above. The left side would have been more prominent, and stood up and was more heavily eroded, so that now the top surface of each side is level but doesn't match, indicating that something weird has happened here. Another spectacular spot that I love to go visit is Mer Bleu Bog in Orleans. The Mer Bleu Bog lies on the floor of an ancient river channel of the early Ottawa River. This channel cuts into the consolidated sediments deposited within the Champlain Sea after the melting of the last glacier about 9,000 years before today. The floor of the bog consists of thick, about 25 to 100 meter deposits of marine clay and clayey silt, informally called Leda clay, surrounded by a sand delta. The Dolman Ridge at the top of the picture and the Ridge Road at the bottom bound the bog to the north and south and are remnant sandbars of the early Ottawa River. This early river was much larger and wider than it is today, drawing away glacier meltwater and occupying many different channels. Most of the channels were abandoned about 8,000 years ago when river discharge drastically dropped after the Hudson Bay became ice-free. And since that time, peat has accumulated in this abandoned channel to a thickness of about 6 meters, creating the Mer Bleu Bog, a radiation or a radiocarbon age of 7,650 years before present from basal peat established the age of this bog. The impermeable nature of the clay that underlies this depression in the channel floor accounts for the slow accumulation of peat. Mer Bleu Bog is one of the largest bogs in southern Ontario, and it is a remarkable boreal-like ecosystem normally found in the far north. Interpretive signs along the boardwalk guide you through this development and biology of a bog. So it's quite a good public awareness geoheritage spot. Another very interesting and odd spot in the Ottawa area that not many people know about are the Penny Sand Dunes in Nepean. This is Ottawa's only inland sand dune complex, and it has survived with minor modifications over about 10,000 years, developed on an old shoreline of the Champlain Sea that inundated the region during the waning stages of the last ice age. This is located just south of the Nepean Sportsplex, so hidden in the trees. This unique ecosystem is home to a number of plant and animal species that can only live in well-drained open areas with exposed fine-grained, well-rounded sand. Like other sand dunes across North America, it was rapidly disappearing due to a lack of understanding of the biodiversity value of this important ecosystem. Nearby residents began planting pine trees in the 1960s, to stop the movement of sand, restricting the dune migration. And in 2011, an organization called Biodiversity Conservancy International took on the huge project of restoration and reclamation of the sand dunes with the help of Trillium Foundation, City of Ottawa, and the NCC. The conservation work continues after the most recent storms this past spring, including adding native plants to create pollinator gardens within the dunes. This group is quite amazing. They're led by a couple of entomologists who are interested in this bug that you can see on the far left of the image, which is called an antlion, and it needs a very particular size and roundness of sand grain in order to trap ants in its little concave hole, and it normally lives in the Sahara. So that's quite interesting. And apparently there are some very unique orchids that live around the edges of the dunes. So well worth visiting. I wanted to show you some fossil and perhaps a little image of what the region might have looked like during the Ordovician. Although some fossils can be found in sandstones, they're fairly rare. Sand is not generally able to preserve fine details. So we tend to find more evidence of ancient life in the limestones and shales of the region. They record the life forms and ecosystems that existed in this area during the Ordovician around 450 million years ago. This diorama from the Smithsonian Institute shows some of the organisms that lived in our area and what they might have been doing. We can surmise from the fossil evidence that the area was much closer to the equator and at the edge of a continent where we might find a similar tropical reef environment today. We also have some fossil evidence of who was living in the area at the end of the last ice age, some 10,000 years ago. They have found a whale and harbor seal bones during building of the airport. And some small capeland fish fossils are found in concretions within the muds of Greens Creek in Orleans. So these are quite interesting. So I've just shown you a few of the fossils that we find within the area and what they might look like in the rocks. So what does it all mean? Simplified geological history of Gatineau, Ottawa. This is from the Ottawa-Gatineau geoscape poster many years ago, maybe 10 plus years ago. I'm just going to put all of these guys up here for us to talk about. 10 plus years ago, a group of people thought that they might interest people more in geology if they were connected to their urban areas. So they started a project called the Urban Geology Project. And out of it came these wonderful public engagement and teaching tools called geoscape posters. So I'm using these images to sort of illustrate what has been happening in the Ottawa area to make the landscapes that we see. In the invitation to this talk, we stated that the region has been home to a huge mountain chain, a tropical beach, a habitat for large whales, and buried under 2 kilometers of ice. So these statements are supported by the observed features we can see in the local rock, some of which we have discussed today. Each rock building interval is followed by long interludes of erosion spanning hundreds of millions of years, creating gaps in the rock record where we have no evidence of what was happening here. We have to look further afield to find clues to fill in the gap. But here's what we think we do know. Our story then starts at the bottom, more than 1 billion years ago, with the oldest rocks in the region, the gneisses and marbles and granites of the Precambrian Grenville province along the Ottawa River, in Gatineau and on the Carp Ridge, as we've seen. Based on the deformation and recrystallization observed, these rocks are interpreted to be deeply eroded roots of an ancient mountain chain that was once as tall as the present-day Himalayas. They were formed between 1.2 and 1 billion years ago, beginning as sedimentary and volcanic rocks, originally deposited along the margin of the ancient North America. They became deformed, metamorphosed, and intruded by magma as a result of collision with another continent. This collision ceased about 1 billion years ago, and the Precambrian mountains began to slowly wear down. In the Paleozoic, between 510 and 440 million years ago, a warm tropical sea flooded the region. We were near the equator at the time, and the oldest Paleozoic rock, the Nepean sandstone, was an ancient Cambrian beach. In the Ordovician, an ocean covered this beach, and limestones and shales were deposited. Trilobites, cephalopods, crinoids, corals, snails, and other shelled animals that lived in the ancient coral reefs can be found by the thousands in the shales and limestones under our feet. About 175 million years ago, in the Mesozoic, the Ottawa-Gatineau graben formed when the land surface moved downward between 2 major fault zones to create the Ottawa Valley. These ancient faults are occasionally reactivated today, releasing crustal stress in the form of moderate earthquakes. The dramatic escarpment that forms the southern edge of the Gatineau Hills between Quillon and Gatineau is a fault scarp along the northern side of the Ottawa-Gatineau graben. During the Quaternary, around 1.7 million to 10,000 years ago, great ice sheets covered northern North America several times. The loose sediments that blanket bedrock in much of the Ottawa-Gatineau area were left by these glaciers and deposited in the Champlain Sea at the end of the Ice Age. You will note the huge gaps in the story between 1 billion and 510 million years, between the mountains and the beach, and between 440 million years and 10,000 years, as shown in the left-hand geological timescale diagram. These are gaps in evidence. We have no rocks that record what was happening at the time. These are called unconformities and are exciting and frustrating for geologists. We have to rely on our colleagues around the world to help fill in those gaps. What we can say here is massive amounts of erosion have happened, where material being transported away from the area during those times to be deposited elsewhere. So that's my story. So I wanted to tell you about some upcoming public education events that you might be interested in. As noted earlier, October 6, 2022 will be the first annual International Geodiversity Day, and we're planning an evening event that will include a talk by Dr. Claudia Schroeder-Adams highlighting her research in Canada's high Arctic, a panel discussion with experts in the fields of critical minerals, hydrogeology, biodiversity, and unique local ecosystems will help us think about how geodiversity affects our everyday lives, including providing communities with clean, potable water, ensuring Canada has the minerals needed to transition to renewable energy, and ensuring we have healthy ecosystems for maximum biodiversity. So if you're interested in that event, it is both in person and virtual, which is exciting. You can go to the Faculty of Science website and look in events and find the link there. And our major public event every year is Geoheritage Day. Rebecca commented on this earlier in the talk. We use this public event to celebrate the diversity of exceptional sites of geological significance within the National Capital Region, some of which you have heard about today. We hold it each year on a sunny autumn Saturday. We invite the public to come out to local parks and green spaces and learn how geological processes have shaped their landscape and given us a glimpse into past environments and provided resources for our use. Geoheritage Day is hosted by volunteers from Carleton University's Department of Earth Sciences and the Ottawa-Gatineau Geoheritage Project, supported by our partners from Cardinal Creek Community Association, the International Biodiversity Conservancy, and our new partner this year, Cantley 1889. During the pandemic, the event transitioned to a digital version, and we added virtual sites, culminating with the release of the Geoheritage Day website, which I encourage you to go have a look at. You just need to Google Geoheritage Day at Carleton and you will find it. We continue adding publicly accessible sites from all provinces so that people across Canada can go out and discover the geoheritage in their own region, and anyone can visit them virtually through the geosite map. So you can watch the Earth Sciences outreach page for updated information about which sites we will be hosting in person this year, and we'd love to have you come and join us on October 8th, which is the Saturday of Thanksgiving. And that is it for me. This concludes my presentation. I hope this small glimpse into the interesting geological sites in the region will inspire you to go visit them in person and come see us during Geoheritage Day on the 8th of October. Thank you so much for your kind attention. I would be happy to answer any questions that you may have.
Thank you so much, Beth. I'm going to speak on behalf of everyone and say that was fantastic. I loved talking and hearing about time with the geoscientists. It just absolutely blows my mind every time. And I'm really thankful that you were so generous and shared all of this with us today. I'm going to open up the Q&A. I think we already have quite a few questions. I think we might also have some points of interest. A question from Terry, who has several samples of Acasta River. Is it knife?
Yes.
Okay, good. And I want to learn all about this from the Northwest Territories. It's been dated at 4.03 billion years.
They are.
I'm could you please bring it into the museum? I would love to see it. Possibly some of the oldest rock known on Earth. The question is, how old is the oldest rocks in the Ottawa area?
So the oldest rocks we have here are probably close to 2 billion years old. I would imagine people who study the Grenville province, like Sharon Carr, who's on the call or on the webinar right now, would have a better idea of exactly how old they are. But yes, the Acasta gneiss is pretty special. And Canada fights with Australia about who has the oldest rock in the world. They have the oldest mineral, which is in a sedimentary rock. So it came from somewhere else, was eroded away and ended up in a sedimentary rock. So it's older than our oldest rock, but we have the oldest rock at the moment. So people are still finding ancient rocks in those two very old continental cores. So I would say between 2 and 1 billion years old in this southern part of the Canadian Shield.
Amazing, amazing, amazing. Terry also had a comment about the Nepean sandstone secret quarry that's found close to the photo that you showed that was used in the construction of Parliament as well as the planetarium. A question from Joanna: what are the rock and fossil collecting laws in this area?
Oh, so that's a good point. Thank you, Joanna. Fossil collecting on any National Capital Commission land is not allowed. So please don't bring your picks and axes when you come to visit any of these spots, because it would not be appropriate, because the property of the National Capital Commission belongs to all Canadians. So we are not allowed to collect in those spaces. I would encourage you, if you want to collect, to join either the Ottawa Lapsmith and Mineral Club, which will take you on field trips to places where you can collect interesting minerals. And the fossil group, I think they're Ottawa Natural History Association. I'll have to look up their actual name. There is a paleontology group in Ottawa too that will be able to advise you better on places where you can collect fossils.
That's good advice. I would love to go on those expeditions as well, join that club when my child is older, and or I find a babysitter. Another question from Joanna: is there anywhere the Green Creek concretions are visible these days?
Greens Creek concretions. Let me think. Well, if there are pathways along Greens Creek, I would imagine you'd have to get down into it and go mucking about to try and find them. I have not been there in quite some time, so I would not be an expert to find them in that area, but they would be pretty obvious because the creek is very muddy, and then the concretions are quite hard, and they're kind of mostly bean shaped. So and then you crack them longitudinally, and then there's a fish fossil inside at the plane of weakness.
An anonymous question, or a question posted by someone anonymous: how frequent are earthquakes in the Ottawa-Gatineau region, and what is the largest earthquake that has occurred here, to your knowledge?
There are earthquakes all the time. Most of them we don't feel. I think I mentioned that when the 2 kilometers of ice was on the surface of the area, it depressed the landscape, and so we have been rebounding from that glaciation ever since the ice left. Very slowly, the surface has been rising. So that contributes to small adjustments in the form of earthquakes, and also any kind of movement, it gets translated onto those pre-existing faults. So we have had, I think in 2010, there was quite a large-ish earthquake. I think it was a 4 or close to a 5. It could be felt in the Ottawa region. I felt it in my kitchen. It felt like a train coming through the house, which was very interesting. The problem with the earthquakes is not that they're large, but that in combination with the laid clay that we have in this area, which is very sensitive, if you have laid clay on a slope and there is an earthquake, it can start mobilizing that clay so that it falls down slope and causes a landslide. So there's a bunch of interesting synergies between hazards in the area that are things that people pay attention to and look out for.
A question from Susan. Is there a driving tour that provides information about these stops? Like, does your map have, I guess, could you make a driving tour out of all the geosites?
You could, are you guys still seeing my last slide here? With
Yes, we
the
are.
stromatolites. So at the very bottom, there's a link, Ottawa-Gatineau Geoheritage.ca. Also, I put in the chat, and hopefully everybody can see it, some of the links to some of the places that I've been talking about. So if you Google Ottawa-Gatineau Geoheritage, you will find the website of this organization, and within it there are some field trips that you could follow the instructions on them, but also a lot of sites that are of interest and publicly accessible and safe to go visit are listed on that website. So you could build your own driving tour. There is no such thing at the moment. And we didn't build one for Geoheritage Day because the sites are generally so spaced apart that you probably would only be able to see maybe 3 in a day getting from place to place. So we thought there are some people in my department who would like us to get a bus and drive people around to all of them, but that hasn't happened yet.
Oh, that would be so fun.
That would be very fun.
Leanne has a question. I'm going to tack one onto that. So Leanne's question was, how is location identified as a geosite? And my question, you mentioned earlier about geoparks. Where would you propose to build one in this particular region?
A geopark. Okay, can you tell me the first question again?
Yeah, how is a location identified as a geosite?
Oh, okay. So basically, we call it's really a loose term. It's nothing technical unless you get into UNESCO and geoparks, when it is a technical term. But for this area, it's a place where you can see something that is geologically interesting, like the picture we're looking at now, and we can say something about it so that we can talk to the public about. So, and for me, that's not entirely true, because geosites may be things that are not publicly accessible. Dr. George Dix, who is also with us today, is somebody who has a pass from the city and the National Capital Commission, so he can drive wherever he likes to go look at rocks wherever he wants to. And so there are geosites along the bus transit ways that are really spectacular, but we can't bring anybody to see them, right? So basically a location is chosen for Geoheritage Day based on being publicly accessible, so that everybody can be safe to go visit them. They're not on anybody's private property, and we have some good information to tell people about them. And then a geopark is an area, it's a region. So there's one in Percé, and there's one that was most recently designated in Bonavista Peninsula in Newfoundland. So it's a regional area where you can see a whole lot of geologically interesting things, as well as being able to have economic development around that. So we have maybe for this area, we might have the rafting tours become part of the geopark, and then they would have interpretation as they do their rafting trips about the geology, as well as the other things they already talk about. So, or you would have a restaurant that has some local food that has a connection to geology. You would have museums and things connected to the geopark. So certainly for this area, if we were going to build a geopark, we would probably pull in all of these places that we've talked about today and some of the other ones that have been identified, and try to see how else we could build an interesting tourist experience, essentially, that would also bolster the local economy. We would want to pick some communities that maybe outside of Ottawa that need a bit of help economically, and sort of build things around supporting them.
Thanks so much. Next is a comment from Susan, just to say thank you. Someone who's no longer in Ottawa. I think that your talk was a little bit bringing Susan back to places that she knew before.
Nice.
So thank you for that comment. And now is a question from Leslie. Beth, could you tell us a little bit about one of the important geologists from the Ottawa area, most specifically a woman?
That would be Alice Wilson. So we have a project on campus that we're hoping to rejuvenate this summer, I have been able to, with a lot of help, get a collection of boulders on campus, and they're currently outside of the Stacy building. And we'd like to move them to a place along the river so that they're more accessible to anybody who wants to look at them, but also in relationship with the river and with those tilted rocks that describe the Gloucester Fault running under this building here. So all of that to say, we would like to name this space a Geoheritage Park, but name it after Dr. Alice Wilson, who was the first geologist with the first female paleontologist with the Geological Survey of Canada. And she had quite a challenging route to her scientific studies. She was doing her work in a time when it wasn't seemly for women to go out to the Badlands and look for dinosaurs and camp. And so she ended up doing all of her geology work in and around the Ottawa area. So as a result, we have really wonderful information about the geology and the geological history and the exposures of bedrock in and around Ottawa from the work that she did on foot and on bicycle and in canoes down the river. She was also fairly instrumental in providing information about the St. Lawrence Seaway and the renovations to that to allow shipping more easily to come into the Great Lakes. So we appreciate her a lot. She was also a professor at Carleton once she retired from the Geological Survey. So she spent some time here at Carleton teaching students, doing field trips, and really encouraging public engagement with geology.
Thanks. That's an excellent answer. I think I've heard about her on a tour of the Nature Museum at some point.
Yeah, there's a plaque in the entrance of the Museum of Nature that highlights her work. And I believe there is, she's one of the trailblazers at the Museum of Science and Tech.
Yeah, I'm going to group the last questions together because we only have 5 more minutes. So Terry also mentioned samples of glendonite from Ellesmere Island. That's interesting.
Yes.
Ray Tannen asked, what's the difference between a rock and a mineral?
Okay.
Another Beth recently visited the woods by the Sportplex. It was marked as closed and wanted to see if that is where the sand dunes are. Alex really likes the idea of the in-person walks and loves finding crystals and would like to join. So we have Alex's email address below so we can add to any list or something that could be of interest. Jennifer asked, did all the rocks between the Ordovician and the Holocene get eroded away by glaciers, or were conditions such that no rocks formed? And then Joanna asked the last question, would like to know if the stromatolites are exposed at the moment. I think that's it, unless it has a last minute question.
I'm madly scribbling. I don't know if the stromatolites are exposed. I haven't been out to look at them yet. I kind of usually wait until close to the last minute because I don't want to scare myself or get depressed because I have zero control over whether they're exposed. There's also dams up the river that muck up things for us. I'll go backwards. Ordovician erosion. Was this caused by glaciers? Maybe was this caused because no rocks were deposited? Unlikely. The thing is, we really don't know. So it could be that much rock was deposited, then eroded away, then deposited, then eroded away, or not deposited for a long period of time because you had mountains and everything was coming off of them. So there's a whole lot of information that we don't have. There are people who study that exact interval and can pull information from around the world to see what might have been happening. But as far as direct evidence, we don't have any. The difference between rock and a mineral. Minerals are the components that make up a rock, kind of like all the components of a chocolate chip cookie. They make up the cookie. So the rock is made of minerals. And so Yeah, that's that question. The sand dunes were closed because of the big storm that came through, and the NCC was working its way through all of the different paths and parks to make sure that they were safe for people to move through. So I understand from Dr. Deng, who is at Biodiversity Conservancy and looking after the dunes, that they are now ready for people to come and visit. But that was why it was closed at the time, just because there's so many down trees and it was just dangerous for people to walk through there. I think that's everything. Oh, Glendonite is amazing, but that's all I know about it.
Thank you so much for sharing all of this with us. What a brilliant way to start the term, to think about the oldest of the old things, but we're thinking about new things at the same time.
Yeah.
Really, everyone really appreciated this brilliant talk, and I'm going to hand it back over to Moira. And look, I'll definitely send the YouTube video link to people so that they can learn about this as well. Thanks so much, Beth.
You're so welcome.
Thank you both again on behalf of the Faculty of Science for participating. It was a great presentation, Beth, and a great conversation. Thank you for facilitating that, Rebecca. Thank you, everybody, for your questions. It was, as I said, I was expecting this to be a lively post-presentation discussion, and it was. Remember, everybody, as Rebecca said, to watch for the recording of today's presentation. We'll be posting it to our YouTube channel. I will send out the link to everybody that registered today. So for those that had to leave early or didn't get a chance to come, they will receive a recording link of today's presentation. And finally, be sure to visit and register for our Geodiversity Symposium being presented by Earth Sciences and facilitated by Beth. It will be hosted at the Canada Museum of Science and Technology from 6 until 8:30 on Thursday, October 6th, in celebration of the UN-sanctioned Geodiversity Day. So thank you very much all. Thank you very much, Rebecca, Beth. Great presentation. Good start of the term. All right. And
thank you, everybody, for listening. I appreciate it.